Thank you for attending the cadence training we had in the Columbia office earlier in the week. I hope you found it worth your time. There were a couple of items that we wanted to clarify after the class, make sure they were more clear. And one of those items was via transitions. Jonathan had drawn up on the whiteboard the via transitions we wanted to use to transition from the CM0 layer up to the CM2 layer. In SIP layout, what that'll end up being is a via that transitions from CM0 to the CM1 layer. Then we're going to stagger 6 microns and have a second via that traverses from the CM1 layer up to the CM2 layer, where we'll continue routing our connect line. I have that set up in this design, so I'd like to show you how it's going to work once it's all set up. Then we'll go back and go through all the steps that I had to do to be able to accommodate this convenient layer transitioning and want to use in your design. So this blue line represents conductor on our CM0 layer. So we're going to use our route connect command. I'm going to select the blue line and start adding some more conductor. And when I'm traveling horizontally on my CM0 layer, if I want to transition to the CM2 layer, I'll select the location where I would like to start adding my via, and I will hold down my right mouse button and select the Add Via command. And we're going to be using what we call a working layer model. In class, we had talked about the alternate and active layer model, where we were just adding a via and it was swapping our alternate and active layer. And that was very convenient when we were trying to add stacked vias. But for your staggered vias, the working layer model is going to be more convenient. And after we do all the setup, we'll also go through showing you how to use the working layer model. It's pretty simple. We're routing along on the CM0 layer, and I'd like to transition to the CM2 layer. So I'll select CM2 in my Add Via form. And what SIP Layout has done for me is, since this is going to be two separate vias, it has already added the first via from CM0 to CM1. That's that stationary via that you see there. And the second via on my cursor is the via that's going to transition from CM1 up to CM2. It is consulting the constraint system, which has given me an exact staggering of 6 microns, which is going to make the squares on the CM1 layer, the features on the CM1 layer, are going to end up coincident to each other, so there'll be no gap there. There'll be exactly 6 microns, and you'll see where we set that up in the constraint system. As I move this second staggered via, it is snapping to 22.5-degree angles. So it makes it very easy to make sure I'm going either exactly horizontally or exactly vertically, whichever you choose. And I'll select this location right here so that we add our via exactly horizontally, and what we now end up with are two vias that are staggered by 6 microns. So we're traveling along on the CM0 layer. Here we have a via that traverses from the CM0 layer up to the CM1 layer. We stagger 6 microns on the CM1 layer, and then we traverse from the CM1 layer up to the CM2 layer, where we continue routing along. And if we were continuing to add more connect line, we would just continue using our route connect command as we're adding more conductor on our CM2 layer. If we'd like to transition back to CM0, we would just right mouse button, select Add Via again. In our Add Via form, we'll select CM0, our target layer. It adds our first via, this time from CM2 down to CM1, giving us our exact stagger of 6 microns. And we can select the location of the staggered via from CM1 down to CM0, and we are again routing back on the CM0 layer. And that would work in either direction. It's giving us the ability to put that second via in at any 90-degree angle that we choose. To help us visualize that, we'll use the 3D viewer. What I'm going to do is pre-select these objects. I'm just holding down my left mouse button and pre-selecting the connect lines and those vias. We can see that they're selected in that purple color now. And if I were to select View, 3D Model, it'll build us a 3D model of those selected objects. And in my 3D model, we're still looking currently from the top of the design down through the design. So we'll select the front button to turn it on its axis, and now we're looking at the cross section of the via structures that we've added, and we can rotate them and zoom in. This large green rectangle all the right way around the outside is just the rectangle that was cut for the 3D viewing. It didn't cut my entire design, just a bounding box of the objects that I had selected. So that largest green rectangle just represents the area that I had cut out of the design. So we'll turn that off because it makes it somewhat more confusing. We're going to turn off our design outline. Oh. We're turning off our design outline here in our 3D viewing layers form. And now what we can see as we zoom in and then pan over, we can look at one of the staggered vias that we've created. And all of these features are relative to each other. So what we could do is extend our z-axis, scale the z-axis, just for the sake of things being easier to see. So we're going to maybe quadruple our z-axis dimension. And now we can visualize our via better. So what we have coming in here is our trace on our CM0 layer. We have a 6 micron pad, metal pad, on the CM0 layer. We had added a named dielectric layer, and that's what this smaller square represents on the D0 dielectric layer, the dielectric between C0 and C1. We have a 3 micron opening in the dielectric, and then this larger green rectangle represents the C1 layer, where from our first via we have a 6 micron square on the CM1 layer, and then from our second via we also have a 6 micron square that are tangential to each other. So we end up with this 6 by 12 rectangle of metal on the CM1 layer. Then on the dielectric layer between CM1 and CM2, we have another 3 micron opening in the mask layer. And on CM2, above that mask layer, we have our 6 micron squared feature of metal, and our connect line on CM2 comes off of that metal square. So I think that was the feature that Jonathan had drawn on the board, and that's what it looks like in the 3D viewer. This is what it looks like in our design, and it was very, very easy to add that via transition from CM0 to the CM2 layer, and then also transition back from the CM2 layer back to the CM0 layer. What I'd like to do now is start with the exact same design that we were looking at in the classroom, and then go through all the steps that were required to get those staggered vias to be convenient and easy to add into our design. So I'm going to go and select File, Open from the SIP Layout text menu, and not save the changes that I made in this design, and open the original design as we were working on it in the classroom. So to start with, one of the most important things that we need to have are the required vias. And unlike in the classroom where I was creating via structures, we did not need to do that. We simply had a via definition that is going from CM0 to CM1, and a second definition that is going from CM1 to CM2. And by setting all of our constraints correctly, we can get the exact physical dimensions that we want for that structure. So to start with, we need a via definition from CM0 to CM1 that has the correct features that we need. So to modify or create a new pad stack definition inside of this design, we can select Tools, Pad Stack, Modify Design Pad Stack. And we can select a pad stack that is likely similar to the one we're going to be creating. So I'm going to find the Shield 3 micron square via. And I don't want to necessarily modify this particular definition. I want to create a brand new via pad stack definition with a new name. So I'm going to select the instance radio button, and it's going to let me supply a new name for this via. For the sake of convenience, I'm just going to call it CM0-CM1. So this is the first via definition that's going to transition from our layers CM0 to CM1. And we'll edit that via definition. And the pad stack editor opens. And what we see with our layers here in this particular pad stack is we have a CM0, a CM1 layer, and a CM2 layer, just like we have in our design. What Jonathan had drawn on the board and what he had suggested in class was that we wanted to define a square pad on the CM0 layer. So I'll select my CM0 layer. We'll say we want a square, and we wanted the square pad on the CM0 layer, the metal pad, to be 6 microns. Similarly, we want to copy that square pad from the CM0 layer to the CM1 layer, where we'll do a paste, and we'll also have a square of 6 microns. Since we're going to be using 2 via definitions to do our transition, our staggered via, our CM0 to CM1 pad stack is not going to have a definition on the CM2 layer. We're going to remove our square of 3 that we have there. We're just going to change it to none. So right now what we have is for this via that is going to connect us from CM0 to CM1, we've got a 6 micron square on CM0, 6 micron square on CM1. What Jonathan also drew is on the dielectric between those 2 layers, we wanted a mask opening of 3 microns. Now, in order to define that, we need named dielectric layers, and we don't currently have that, and that's why we don't see those dielectric layers inside of our pad stack. So what I'm going to do is do a file, update to design and exit. It'll send this new pad stack with its changes back to my design and save it in the design for me. And in order to accommodate named mask layers is what we need to do so that we'll see them in our visibility folder tab once we're done. Notice that our visibility folder tab, we don't see our dielectric layers. If we were to go back to our cross-section form where we defined these 5 CM layers to begin with, it defines the cross-section of our design. If we were to select setup, cross-section, this is where we see our cross-section editor shows us the different layers of the design, and it is showing us the dielectric layer between each of our metal layers. And all we need to do is put a name in there so that we can assign features and see those features in the SIP layout and assign features in the pad stack editor. So above CM0, we'll call this our D1 dielectric layer, and then between CM1 and CM2 we'll call that our D2 dielectric layer. And we could similarly do the rest as well, but to make this video an example shorter, I'm just going to do the transition from C0 to C2. The others would be exactly the same. And now that we've named those dielectric layers in our cross-section form, when we close the cross-section form, we see that first of all, our visibility folder tab now includes our D1 and our D2 dielectric layers. What that will also do is now when we go and edit that pad stack, we'll see that it also includes the D1 and the D2 dielectric layers. So we'll go back to Tools, Pad Stack, and modify our design pad stack. The pad stack we'd like to modify is the one that we were calling CM0 to CM1. So we'll select CM0 to CM1, we'll edit it, and sure enough, now we see our D1 and our D2 dielectric layers. And what we had said is, okay, we are going to have a 6 micron square on CM0. It's going to pass through a 3 micron hole in the dielectric layer, and we'll have a 6 micron feature on the CM1 layer as well. So we'll select our pad type for the D1 layer, set it to square with a width of 3 microns. And that is what's going to give us our 3 micron opening in that dielectric layer. we will do a file and update to design and exit, update our SIP layout and update that definition in our SIP layout database. And then what we'll do in our pad stack editing command still, we'll select our CM0 to CM1, the one we just created, set a radio button to instance so that we can now create a second definition that we'll call CM1 to CM2. And we'll edit this second pad stack definition now. And what we'll do is we'll take our CM0 feature, and in this particular pad stack, we don't need it there. We're going to copy it instead to our CM2 layer. We'll paste it in there. And we'll come back and take our D1 3 micron square. We're going to copy that up to D2. And then we'll come back to CM0 where we want to make that none. We don't want a feature for this pad stack definition on CM0, nor do we want a feature for this pad stack on D1. We'll set that to none as well. So now in the first pad stack that we created that we had named CM0 to CM1, we had a square feature, metal feature on CM0, a 3 micron opening on D1, and a 6 micron square on CM1. For this pad stack definition that we named CM1 to CM2, we've got our square of 6 microns on CM1, the dielectric opening of 3 microns on D2, and then a 6 micron feature, metal feature on CM2 as well. We'll select File, Update to Design and Exit to update those changes back to SIP layout, where we now have the 2 pad stack definitions that we will require to have us be able to transition from CM0 up to CM2. So the bulk of the magic of getting all this to work is in our constraint system. And one of the most important, or certainly the first constraint that we'll set is the idea that the vias that you use for routing are controlled by the via list in your physical constraint set. So what we'll need to do is add those 2 new vias to our via list for our physical constraint set. So we'll go into Setup, Constraints, Physical, to open our Constraint Manager. And in our constraint manager, as we had mentioned, we have 3 main domains: our electrical domain, our physical domain, and our spacing domain. So in our physical domain, we'll use our physical constraint set folder to look at our different physical constraint sets. And in our default physical constraint set, if we scroll across, we can see our via list. And if we select the cell for the vias for our default physical constraint set, it shows us our current set of vias that we're allowed to use for routing. We'll scroll down the list of available vias, and we should find the 2 new vias that we had just created. And we'll add CM0 and CM0 to 1 and CM1 to 2 to our via list. And we can see down in the image below at the bottom of our constraint manager, these 2 vias on the right represent our via that goes from CM0 to CM1. We'll then also add a via from CM1 to CM2 to make our transition from the CM0 layer up to the CM2 layer. The order of this via list is relatively important when we start using our working layer model of adding these vias. What we want to do is make sure that our shorter vias, CM0 to CM1 and CM1 to CM2, are at the beginning of this list. When we try to add a via from CM0 to CM2, the working layer model is going to try to use the first via in the list that will allow it to get between the two layers we are trying to transition to. So we'll move CM1 all the way up in the list, and right below it in the list, we'll move CM1 to CM2. And those two vias are now included in our via list in our physical constraint set. Also, in our physical constraint set, we're going to want to set our BB via stagger distance. We're going to set our maximum BB via stagger distance on our CM1 layer to 6 microns. Now, the reason we're selecting 6 microns is because on that CM1 layer is that plane layer between CM0 and CM2. So we're going to have a via at CM0. It's going to go up to layer CM1. We want to travel exactly 6 microns on CM1. That's what gives us our stagger, and then put the second via from CM1 to CM2. By making that exact distance 6 microns, the 6 micron square metal pads that are on that CM1 layer will be coincident. They will, their edges will touch. And this constraint will space those vias center to center distance at exactly 6 microns, which will make their edges touch. And then finally, another constraint we're going to have to set is in the same net spacing domain. I kept saying there were 3 main domains: electrical, physical, and spacing. And in general, there are. But when we're working with blind and buried vias, we often need to consider the same net spacing domain as well. It works exactly the same as the spacing domain, except in the spacing domain, it sets minimum distances for objects on different nets. So for instance, the edge-to-edge spacing of a via on one net to the edge of a via on another net. And as the name suggests, the same net spacing domain applies to vias on the same net. So what we need to do is go to our same net spacing constraint set folder, and on that CM1 layer, that stagger layer, that's the plane layer. We're trying to transition all the way from CM0 to CM2. We are going to have a small 6 micron stagger on that CM1 layer. So what we're going to do is set our same net via to via spacing rule for the CM1 layer. We have to first tell it that we are enabling the DRC, the same net DRCs for that layer. So we're setting that cell to true. And if we scroll over, what we're going to want to set is our blind and buried via to blind and buried via spacing rule. On the CM1 layer, we want to set that to 0. That's what's going to allow us to have those 6 micron square metal pads on CM1 be adjacent to each other. They're allowed to have a 0 micron clearance, and their edges will touch. Now we've set up the constraints required to make our vias work. Now what we're going to do is go back to our add connect command. We're going to select route connect from our SIP layout text menu. Now, another thing we're going to do is in our options form of the control panel, the default model for adding vias in your design is called the active and alternate model. And that's what we were using in class, where we have an active class that we're routing along on, and then an alternate class. And that's the layer that you'll transition to when you decide to add a via. And it's fine. It's a very common model for adding vias. However, in this particular case where we're trying to add staggered vias, multiple vias to transition from C0 to C2, the working layer model is probably easier to use. So once we're in the add connect command, in our options folder tab of the control panel, we'll left click here where it says alternate, and we'll change that to WL. That's the working layer model. When we're using this working layer model for adding our vias, one of the things we first do is set which layers of the design we'll be working with. Now, in your particular design, there's not a tremendous amount of layers, so we're just going to turn them all on. If we had a very large number of layers, say a 28-layer design or something, we may be working only with the top 14 layers or the bottom 14 layers, or some set of 6 layers, and you would only turn those layers on for your working layers. In our case, we don't have too many layers, so we're just going to turn them all on. And we'll notice that in our Options folder tab, now we only have a single layer. That's the layer that we're going to be routing on. So we'll select our connect line that's on our CM0 layer, and as we're routing along, it automatically changed our active layer to match the layer of the wire that we had selected. So we're routing along on our CM0 layer. When I'd like to add a via, I can hold down my right mouse button and select the Add Via option. In working layer model mode, the Add Via form comes up, and I am going to select the layer that I would like to transition to. And we'd like to transition to the CM2 layer. And when we select CM2, our first via from the CM0 layer to the CM1 layer is added for us. And we notice that we get our exact stagger of 6 microns, so that when we line up our staggered second via, either horizontally or vertically, the two metal shapes are coincident, they touch. And as we spin around our first via, we're snapping at 22.5-degree increments. So it's very easy to make sure we stagger our via either exactly horizontally or exactly vertically. And when we click it into position, we can then continue routing along on the CM2 layer. Similarly, as we're routing on the CM2 layer, when we'd like to add a via, you can either, as I did before, click the position you'd like to add the via, and then hold down the right mouse button and select Add Via. Or if you double click at a location, it also goes into the Add Via command. This time, as we're routing along on the CM2 layer, we want to transition back to the CM0 layer. And just like before, it adds our first via from CM2 down to CM1, gives us the stagger we want from CM1 down to CM0, and we can continue routing along on the CM0 layer now. So our blue line represents the metal on CM0. We have our vias, our staggered vias that transition from CM0 up to CM1, staggers exactly the 6 microns we want to the CM2 layer, and then we route along on the CM2 layer. Similarly, when we wanted to go back, it dropped a via from CM2 to CM1, staggered the exact distance we wanted, and dropped a second via from CM1 down to CM0. And just to super verify that we got what we wanted, what we'll do is select these elements again and select View 3D Model. And when we look at the 3D model, we'll look at the front side of the model again. We'll spin it down a little bit. As I mentioned earlier, the largest green rectangle is just a cut rectangle, the portion that got cut out from the design. So we'll go into our layers and turn off that design outline. And for the, much like we did before, for the sake of being able to see what's going on even better, we'll stretch our 3D model in the Z-axis so that we can see our transitions better. Here's our conductor on CM0, has a 6 micron square on the CM0 layer, a 3 micron hole in the dielectric layer, a 6 micron square on CM1 that is tangential to the 6 micron square on C1 also from the staggered via up through the 3 micron hole in the mask to a 6 micron metal pad on the CM2 layer, where we then continued routing. So the magic was all in the constraint set. That was in fact a bit of setup that we had to do. So to recap, what we had to do was first define 2 separate pad stack definitions, one from CM0 to CM1, a second pad stack definition from CM1 to CM2. To create those correctly, we had to name our dielectric layers between those metal layers, and then we had to add those vias to our via list in the physical constraint set for routing. Also in the constraint manager, we set the maximum BB-via stagger distance in the physical constraint set to 6 microns. That's what gave us our exact 6 micron stagger on that CM1 layer. And since the metal on the CM1 layer for each of the pad stacks was also 6 microns, it made the edges coincidental. And then finally, we had to use the same net spacing domain in the constraint manager to turn on our same net spacing rules for the CM1 layer and set our BB-via to BB-via spacing to 0 for the CM1 layer so that our two staggered vias, the two pads on the CM1 layer, were allowed to have a clearance of 0. And that's what made them coincidental, and we'll make them all one shape in the mask. If you have any questions about that or have any trouble getting that set up, just shoot me an email, palumbo@cadence.com. And the other items from the class that need to get settled out, I'll probably send you some more information a little later in the week. Thanks again. Shoot me an email if you got any questions. I'll talk to you later. Bye.